In this final example looking at trees, we're going to have the weights recorded in a mileage chart, and we're going to talk about how we can solve this problem without actually drawing out the full connected graph. So the Colorado Parks and Recreation Association wishes to build bicycle trails that connect the cities in the table. Use Kruskal's algorithm to determine the minimum cost spanning tree that would link each city and create the shortest distance for the bicycle trails. If the cost of building the trail is $5,500 per mile, let's determine that minimal cost to build these bicycle trails. Now in this case, I'm just going to go ahead and put down my different vertices. We're going to build an auxiliary graph in order to keep track of not building any circuits too early. And I'll just use the first letter of each of these cities. So this will be for Aurora. That'll be for Boulder, Denver, Inglewood, and Golden. And then keep in mind that the numbers in this table are symmetric across this diagonal, so I'm only going to have to look at half this table, so I'm going to cross off this top half so those numbers don't distract me. Alright, so down here looking at these numbers, the smallest weight that I would have would be this 8, connecting Denver to Inglewood. So I'm going to record the weight, and then on my auxiliary graph, I'm going to go ahead and draw in a connection between those two so I can keep track of what edges I'm grabbing. The next lowest weight after that is from Denver to Aurora, with a weight of 9. So maybe I'll circle these so I keep in mind of what numbers I'm grabbing. So from Aurora to Denver, let's draw on that edge as well. Okay, from here on out I'm going to have to be careful not to build any circuits. The next lowest number after this is 15. That's from Aurora to Inglewood. Yeah, if I were to draw that in right now, I'd create a circuit right here. So this 15 is out. This 16 from Denver to Golden. Yep, that does not create a circuit, so that one's good. So I'm going to go ahead and mark that. Alright, now at this point in time, I have to be careful about finishing this, because keep in mind, you're not creating a circuit, so we have to be, there's a lot of different ways that I could connect B to the rest of this graph. I'm going to have to use these numbers to tell me which edge I want to include. So coming back here, the next lowest weight is going to be the 21. That connects Inglewood to Golden. Yeah, if I draw that in, I'm going to build a circuit right there, so that one's out. The next lowest number is this 26 from Golden to Boulder, and that one's going to work, and that's how I get B included in this graph. So I'm going to go ahead and connect those two and record that weight. Now keep in mind on this particular graph there are 5 vertices, so your tree will have 4 edges. And then notice over here I do have 4 weights recorded. All right, so those are going to be my 4 edges. Ultimately then, adding these numbers up, we get that the trail will span 59 miles. And this is then going to be the connections that we're going to have to build to be able to connect these cities. And then the total cost, if it's going to be $5,500 per mile, and I have 59 miles. Ultimately then this trail is going to cost us $324,500. Okay, so we didn't need to necessarily build the full graph on this one. We could use this auxiliary graph just to keep track of what edges we would want to grab, so that way we don't build any circuits and we get the number of edges that we would need for our spanning tree.